This video is going to cover the topic of backtracking. Let's put that as our topic along with the date at the top of our page. Our essential question will be, how do we use backtracking to find an unknown number? We'll start by defining backtracking. Backtracking is the process of finding an unknown number by working backwards from the answer. Let me show you a quick example. So here's a simple question. What number would you need to multiply by 3 to get 6? Right? So we know that 6 is our answer. It's the product of our number times 3. We're going to work backwards to find the number that fits the description. We could think to ourselves, well, some number, here's a variable that represents my missing number, times 3 equals 6. Right? So we could say to ourselves, oh, right, 2 multiplied by 3 is the unknown number, right, because 2 times 3 would give us 6. So the unknown number we're looking for is 2. This example is a really basic one, right? We probably wouldn't need a fancy strategy to know that our missing number was 2, right? But I'm going to show you how we can use these boxes, these series of boxes, to help us organize our thinking in what we call backtracking. Here's an example of a backtracking problem. I'm looking to figure out a mystery or special number. So I have n here that's representing, see my n here? My n is representing an unknown number. I know that a series of operations have been performed to my number, and it resulted in the value 10. To backtrack, we work backwards to find out what we started with. The last operation that was used was subtracting 4. That was the last thing that happened to my mystery number. So I'm going to do the opposite, or what we call the inverse operation. So instead of subtracting 4, going backwards, I'll add 4. Well, 10 minus 4 would be 14. So this box must have been filled with a 14. Then I'm going to do my opposite, or inverse operation on the previous step. So the step before was multiplying by 2. To do the opposite, I'm going to divide by 2. 14 divided by 2 gives me 7, right? Then once more, I'm going to look to go backwards to the beginning. The first step back here was that I had added 4. So going backwards, I'm going to do the opposite and subtract 4. Well, 7 minus 4 is 3. So the number I must have started with was 3. I'm going to say that my number has a value on this particular problem of 3. I always like to double check that I did it correctly. So if my number was 3, 3 plus 4, yep, that makes 7. Then my 7 was multiplied by 2, that makes 14. And then I subtracted 4, which is 10, which is what I should have gotten. So I must have done it correctly. It all checks out. Let's do another one. Here we have a new mystery number, right? N represents my number. It's the variable I've chosen to use. And I see that some operations were performed, and I ended up with 20. Let's go ahead and work backwards to find the value of our variable. The last step that was performed was subtracting 20. So to do the opposite, I will add 20. 20 plus 20, this box must have a 40 in it. The step before that was to multiply by 8, so I will divide by 8. 40 divided by 8 is 5, so that box must have had a 5 in it. The step before that was dividing by 2, so to do the opposite, I'm going to multiply by 2. 5 times 2 is 10, So I think my mystery number must have been 10. But just like before, I'm going to double check. We always want to double check our work so we'll know that we're right. So if our number was 10 and I divide it by 2, I do get 5. Then if I multiply that by 8, I get 40. And then if I subtract 20, I get 20. And that's what I should have at the end of all my operations. It checks out, so I know I did it correctly. We'll do one more, but this time I'll set it up with you or for you, and then you'll pause the video and you'll get to see how you did. So we have our mystery number n. A series of operations have been performed and it ended up with a value of 30. So take a moment to pause and see if you can backtrack, go backwards, and figure out what my mystery number is. Pause the video and then when you're ready to check, see how you did. How'd you do? Our mystery number, the variable n, represented 9. And I can double check, right? Because I can do 9 minus 6 gives me 3. 3 times 5 is 15. 15 times 2 is 30. And that's what I should have gotten. So remember that this video's purpose, the essential question, was to see how we could use backtracking to find an unknown number.